Alright, the last section for this week is section 8.1. Okay, we'll split it up into 2 days. Basically the goal here is we're going to be working with triangles that don't have 90-degree angles. Okay, and we're going to solve them. To solve them means you've got to figure out how big are all the sides, what's the measure of each angle. So there's 6 things you need to find. 3 sides, 3 angles. I'm always going to give you some information to start with. Depending on the information that I give you is going to control how you solve the problem. There's 2 types of laws we're going to study. One of them we're going to do this week. One of them we're going to do at the beginning of next academic week. This week we're looking at the law of sines. The law of sines can be used in certain cases. The other law is the law of cosines. That can be used in other cases. Okay? And it all depends on what information you're given to start with. All right, so I'll talk about what cases do you use the law of sines for. Okay, that's what we'll look at today. So first of all, if you have a triangle that doesn't have a 90-degree angle in it, that's called an oblique triangle. More specifically, there's 2 types of oblique triangles. You could think of like an acute triangle, where all the angles are less than 90. A specific example of that is an equilateral triangle. And then you could also have an obtuse angle, where you have one angle bigger than 90. Now, could you have 2 angles bigger than 90 in a triangle? No? How come?
Because the measures of the angles in a triangle adds up to 180 and you have to have 3 angles.
Yeah. The angles have to add up to 180, so if 2 of them were bigger than 90, that wouldn't leave much for the 3rd angle. Okay? So, acute and obtuse, those are the 2 kinds of oblique triangles. Now, when I sketch things, I don't sketch anything really to scale. I'm always just going to draw a triangle like this and label the sides and angles. I'm not necessarily saying that this angle is bigger than that one, even though it might look that way. I'm just using my diagram to understand what is across from what. Okay, it's not drawn to scale. And that's the diagram that I always use for solving oblique triangles. You can draw it any way you want. If you want to draw it so it looks like an acute triangle, that's fine too. The important thing is when you label it, A is across from alpha, B is across from beta, and C is still the 3rd side, but now we've done something different. The 3rd angle isn't a right angle anymore. So we had to give it a name. And does anybody know what that Greek letter I just circled is called? That's called gamma. G-A-M-M-A. Gamma. So sketch your triangle, whatever scale you want to use, just keep A across from alpha, B across from beta, and keep C across from gamma. That's what's important. Now, if gamma is not 90 degrees, then you don't have a right angle. And what else don't you have? If you don't have a right angle, then you also don't have this either. Yep. It could still be isosceles if you had like if you had a right angle, like an obtuse angle like that, and those 2 sides were the same. So even though that's not a right angle, it could still be isosceles. But there's something else you don't have. You don't have a hypotenuse. No right angle, no hypotenuse. No hypotenuse, no Pythagorean theorem. So you cannot use Pythagorean theorem. You also can't use SOHCAHTOA, because SOHCAHTOA is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. There's no hypotenuse. Okay, so you can't use that either. So, what you're going to end up using is the law of sines. Once you know both the law of sines and law of cosines, you have to decide which one to use when. Okay. I'm showing you the cases right now for when you use the law of sines. Law of sines is used whenever you know 2 angles and a side. And the placement of the angles and sides that you know can be two different ways. You can know two angles and the side that connects them, or you can know two angles and the side that doesn't connect them. So as a picture, angle side angle might look like this. 10, 15, 105. That's a picture of angle side angle. Two angles, and the side is between the two angles that you know. Side angle angle could be something like 15, 100, and then I can pick either side, but not the one that connects the two angles. 12. That's an example of side angle angle, because this time the side that you know does not connect. It's not between the two angles. And there's one more case that you can use law of sine with, and that's side angle. So that would look something like side angle. You know, two sides and an angle, but it's very important that the angle you know, it's not between the two sides. It's not this one right here. If the angle was between the two sides, you can't solve that yet. That's a different law. That's law of cosines. So SAS, or side angle side, that's a problem you need law of cosines for, and side. Okay, notice I didn't put side up here. That's because you can't do that one with law of sines either. So for most of these, you can write them forwards or backwards. Like if you put angle, side, instead of side, angle, that's the same thing. ASA, if you really want to reverse it, you could put ASA. That's okay. And side angle, just leave that one in that order. That's nicer. All right. So any questions on that? All right. So to solve those three types, we're going to use the law of sines. So on this test, you're not really going to have to decide between should I use law of sines or law of cosines. Every problem is law of sines. On the next test, though, I'm going to put some of these problems again. And then you're going to have to decide between the two. Okay, so what I'm going to do is kind of go through a little bit of an explanation of law of sines. Law of sines is derived from SOHCAHTOA. Basically, you can use that to figure out this formula. And once we figure out what the formula is, we never have to go through it again. We just memorize it and we just use it. Okay, but I'm going to try to explain a little bit about where it comes from. So, we're going to start by looking at that triangle. Okay, I tried to sketch it so it doesn't look like any of the sides are equal. In fact, I can even bring this side in a little so it doesn't look like a right angle at the top, because I don't want it to look like a right angle. So it's just a scalene triangle. All the sides are different lengths. No right angles in there anywhere. And what I'm going to do is I'm going to break this up into two triangles, because we already know how to work with right triangles. And if we do that, we can kind of figure some stuff out. Okay, I need to label some sides here. I'm going to call this side A, and I'm going to call that angle alpha. I'm going to call this side B, and what's the name of the angle that's across from B? Beta. And I'm going to call this H, not because it's a hypotenuse, because it's the height. Okay, so just don't confuse that. H is the height. I'm not going to label the third side on the bottom. I don't need that, and I'm not going to label the third angle right there either. I don't need that. Okay, what I'm going to do now is I'm just going to forget about the right half for a minute, and I'll come back to it. I just want you to focus on this left triangle. I want to use a trig function that would involve this angle, this side, and this side. So I've got a right triangle, so I want you to think Sakatoa. And what's the name of the side that we've labeled H from the perspective of beta? Yeah?
Opposite.
It's opposite, so keep that in mind. And what's the name of the side we've labeled A in that triangle? Yeah? It's hypotenuse. So which trig function has opposite and hypotenuse in it? Yeah? Sine. So the sine of my angle equals opposite over hypotenuse. And what I want to do in that formula is get h by itself. Okay, so Shauna, what would I have to do to get the a on the other side and get h by itself?
Multiply both sides by a.
Yeah, we'd multiply both sides by a, and you have a sine beta. So now you have a formula for the height of the big triangle. It's a sine beta. And I'm just going to call that box 1. Any questions on that formula? Okay, I'm going to do the same thing again. Let's go to the other side. I want to come up with a formula for the height, but this time I want to do it using this, that, and that. Okay, so Jayan, what's the name of the side that we've labeled H from the perspective of alpha?
Opposite.
And side B? Hypotenuse. So it's the same trig function again. Sine of alpha equals opposite over hypotenuse. H over B. And Gracie, how would I get H by itself? Excuse me. So yeah, multiply both sides by B, and we're going to get B sine alpha equals H. So now you have another formula to find the height. And let's call that box 2. Any questions on that formula? All right. So now let's look at the whole thing. We've got one formula to find the height. That's formula 1. And we have another formula to find the same height, formula 2. But it's a different formula. So what else does that mean? If formula 1 gives me the height and formula 2 gives me the height, there's another fact I can write down inferring from that information. Crazy? Yeah. What's in box 1 equals what's in box 2. And that's basically the law of sines. If you write that idea down, and then we're going to rearrange it and make it look a little nicer, that will give us the law of sines. All right, so let's write down that idea. Box 1 equals box 2. A sine beta equals B sine alpha. Now, what I'd like to do is I want to put A over on the same side as alpha, and I want to move B over to the same side as beta. So how would we move A to the right side? Yeah, Leo?
Divide both sides by A.
We divide both sides by A. And how would I move B over to the left side?
Divide both sides by b.
Divide both sides by B. And what's going to happen? A's cancel, B's cancel. And the only thing you have to be careful about when you divide by a variable is something that could happen. What are you not allowed to divide by ever? Yep. So we don't like to leave a square root in the final answer because that's just kind of a convention. But this is more of a rule in math, something you're never allowed to divide by. You're not allowed to divide by 0. But I can guarantee you neither A or B would ever be 0. How come I can guarantee that? Yeah?
Because you can't have a length of 0.
Right. If I had A or B 0, I wouldn't be dealing with a triangle. So no matter what, A or B will never be 0. We don't know what they are, but they're not 0. So you didn't divide by 0. So now you get sine of beta over B equals sine of alpha over A. And that is the first two parts of the law of sines. You could put sine of beta over b or sine of alpha over a first. It doesn't matter. Sine of alpha over a equals sine of beta over b. And does anyone have a guess what the third part would be based on the pattern for the previous two fractions? Yep.
Would it be sine gamma over c?
Yeah, it's sine gamma over c. I didn't prove the third part. But you could, doing the same thing we just did again in the triangle, just draw the height from a different vertex instead of the one I picked. And that's the law of sines. So I consider each fraction here, I call it like the first part, second part, third part. You never use all three parts at the same time. You're either going to use the first two, the last two, or the first part and the last part. One fact you can still use to help us, though, is that all the angles add up to 180. On a flat triangle drawn in the plane, all the angles add up to 180. If you deal with other kinds of triangles, then they don't. Triangles that are drawn on like a sphere, like if you connected the North Pole, Boston, and London, it makes a triangle, but it's not a triangle on a flat surface, it's on a curved surface of the Earth. We don't really study those kinds of triangles in pre-cal. Okay? So this fact is true for us. All right, so now that I've given you the formula, we're going to try to solve that triangle. Okay. First thing I'm going to do is make a sketch because I want to see, is it one of the three types that I mentioned? ASA, SAA, SSA. So let's make a sketch. So I'm going to put A. Alpha has to go across. I'm going to call this B. Beta has to go across. C. And gamma. So based on that picture, what type of triangle is that using the three letters, the S's and A's? Yeah. Yeah, it's a side, angle, angle. Or if you said angle, angle, side, same thing. So, look at your chart, or look at your notes. Side, angle, angle. It's that type right there. That's one of the types we should use law of sines for. Alright, so now that we know it's law of sines, we're going to take all that information, we're going to put it into a table just to kind of organize our thoughts. A is 4. B, we don't know. Put a box around it. C, I don't know. I'll put a box around that. Alpha is 20. Beta is 60. And gamma, we don't know. Now, looking at that table, does anybody notice something about it? There's a pattern in that table that actually, if you just make the table, you can tell it's a law of sines problem. Did anybody notice anything about the table? There's a yeah?
Well, like using the formula we just got, we can solve for B. We have everything. We
Yep.
Beta.
We can solve for B. We have enough information to solve for beta, definitely. But does anybody notice anything about the arrangement, like where the numbers are in the table right now? Just based on where those numbers are, the three that I know, the placement of them, I can tell that that's a law of sines problem. Yep.
Because you have a side angle.
Because I have a side angle. Yeah, we know that there's two sides in an angle, so that's always law of sines, no matter where the angle is. But there's something else about the way that table's laid out. Think about side, side, side. Is that a type I said we're doing today? So think about how it would look if you put a side, side, side and filled those numbers in. That table would not have the idea that I'm thinking of right now. Yeah?
If you only have the sides, you wouldn't have an angle with the formula.
You wouldn't have an angle, right? And if you're missing all the angles, you don't have a row that's complete. Okay? You don't have a row that's full. If you don't have a row that's full, you can't use law of sines. I'm looking at that table. I have a row that's full. I know I can use law of sines. Same thing with side, angle, side. If you know a side, angle, side, you wouldn't have a row that's complete. That's why we're not doing that one either. All right. So we have a couple options what we can find first. We could do B, or we could do gamma. What you definitely can't do is C. You don't have enough information to find C directly yet until you get gamma. So let's do gamma first, because that's pretty straightforward. What's gamma here? It's 100. Now, when we did these kind of problems in right triangle trig, would you use what we just calculated to find other things? No, why not, Gracie?
You would use it because it's not like definite.
Hey, it wasn't given to you, so if we made a mistake finding it and you use it, other things could be wrong. So in right triangle trig, we don't use it. When you're doing law of sines, you have to use it. There is no way to find C without using gamma. So if you got gamma wrong, you're automatically going to get C wrong. But just because you get gamma wrong, gamma has nothing to do with B. You could still get B right. All right? But there's going to be more of this dependency when we do it this way of you're going to have to use things you found to find other things. There's just no way around it. Okay. So now we could find B or C. Let's do B first. Okay, so find B. You're always going to use the row that has everything in it. So row A. I'm going to go back and look at my formula. This is the part of the formula I'm going to use. And then I'm going to use that. For now, I'm not using the third part. So sine of alpha over A. So let's fill that in. Sine 20 divided by 4 equals, and now we need sine beta over B. Sine 60 over B. What is that thing called that I just created? I have a fraction with another fraction and an equal sign between them. Yeah?
A ratio?
Yeah, it's kind of like you have a ratio on the left and a ratio on the right. When you have two ratios together equal to each other, there's another name for it. And it's usually, you study this thing at the same time you study ratios. It's like in the same section. Probably in geometry or something. Anyone remember what that's called? How about how you solve that? Does anybody remember the technique you used to solve that? Yep.
Do you use cross multiplication?
Yep. You cross multiply. And now, does that remind anybody what that's called? You always use cross multiplication to solve a, begins with a P. Yeah?
Proportion?
It's a proportion. So we have two fractions equal to each other. It's a proportion. We're going to cross multiply. So we get 4 sine 60 equals B sine 20. And now we want to get B by itself. So what would I do on each side? What would I do on each side to get B by itself?
Divide by sine 20.
Yeah, divide by sine 20. Don't even worry about what sine 20 is. I'm never even going to know what it is in this problem. I'm just going to divide by it. Divide by it. And now, that's my answer. I have to type that in, but I'm just going to type the whole thing in at once. All right, so first make sure you're in degrees. Make sure your calculator turns on. There you go. So 4 sine 60. It's important you close the parenthesis if you're going to type it all in at once. Divided by sine 20. Not too important you close the parenthesis here because nothing else is coming after it, but if you want to close it, go ahead. So we get 10.128. And that's B. So don't round anything off until the very last step. Okay? Don't take the sign of 60 and round it, and then multiply by 4 and then round it again, and then take the sign of 20 and divide by it and then round again. That's too much rounding. Okay, so do it just like that. All right, so now we've got A and B. Could I use Pythagorean theorem to get C? No, not complicated.
Because we don't have a hypotenuse.
Yeah, we don't have a hypotenuse. If you use Pythagorean theorem, you're assuming gamma is 90. It's not. It's 100. So we have to find C the same way we found B. But now we have a choice. You need to use a row that has everything in it. You have 2 rows with everything in it. Which row should I use? A or B? Yeah.
A, because it was given to you.
Yeah. Use A because it was given to you. So we're going to start with sine of 20 over 4, just like we did before. Sine 20 over 4. And can someone tell me what I would put on the other side? Okay.
Sine 100 over C.
Sine 100 over C. Now, once you do enough of these cross-multiplying problems, you can kind of do the middle step in your head. And I'm just going to get C by itself, all in one step. C is going to be 4 sine 100. And then I would have to divide by the number that would be next to C when I cross-multiply, sine 20. Any questions on how I did the cross-multiplication there? So 4 sine 100 equals C sine 20, then divide by sine 20. Great, and now take that in. If you have it on your calculator, you can just pull up the last calculation you did and just change one number. So put in 100, and now we get 11.518. Any question on that? Now, to quickly look at it and check for something that could be obviously wrong, does anybody remember what's the connection between sides and angles in a triangle? Something I can look at quickly and make sure that things are paired up reasonable. Yep?
Don't the largest angles correspond to the or are opposite to the largest side?
Yeah, the biggest side should always be across from the biggest angle. Looks like that happens here. Smallest side, smallest angle. That's good. And the other thing is any 2 sides added together should be bigger than the third. So 4 and 10 gives me 15. That's bigger than 11. 10 and 11 gives me 21. That's bigger than 4. And 4 and 11 gives me 15.5, which is bigger than 10. So any 2 sides added together should be bigger than the third. If that doesn't happen, then something's really wrong. Okay. So, questions on angle side? All right, let's look at this one. Okay, what type is this one? Yep, it's angle, side, angle, because this time the side you know is between the 2 angles. If we go back and check out our list, angle, side, angle, yep, it's one of law of sines. It's one of the 3 types. All right, so we don't need to make a diagram. They already did that part for us. So let's just go right to the table. Now, in order to use law of sines, just as a reminder, what's the trick? If you look at the table and the table has what? Yep. A full row. So let's see what happens. A, I don't know. B, I don't know. C, I know. How do I know C is 4? It's not labeled as C. But how come it's C?
It's opposite of gamma.
It's opposite of gamma. That's how you have to figure out which one is which. It's opposite what? So 40 is opposite B. So that's beta. 45 is opposite A. So that's alpha. Now, looks like we kind of have a problem, right? There's not a row that's full. But could you find something that would make a row full? If you can, then you can still use log signs. Yeah?
You can find gamma.
You can find gamma. We know two of the angles. Add them up, you get 85. Subtract from 180. That would mean gamma is how much?
95.
95. Now, it's very important that you get gamma right. It's more important even in this problem than the last one. Why? Why do you think it's really important you get gamma right? Yep.
Because you have to use that and it's going to be full row.
Yeah, you have to use this row to find A, and you have to use the bottom row to find B. So if you got gamma wrong in this one, everything's wrong. In the last problem, it wasn't quite as bad. If you made one mistake, you could still get part of it right. No, not in this one. So gamma 95, double check it, we're good. Okay. Now we'll set up our proportion. Whether you find A or B first, it doesn't make a difference. You can do either one. So Leo, which one do you want to do first? A or B? A. Can you set up my proportion? Find A?
Sine 45 over A equals sine 95 over 4.
Sine 95 over 4. And Trevor, could you tell me, you don't have to give me the decimal, but just tell me the calculation that I would do after I cross multiply and get A by itself. Or sine 45. Yep. Sine 95. Yep, perfect. Okay. So there's your calculation and getting A by itself. Now we just type that in. Did anybody type that in and have the decimal? Yep. What'd you get, Caleb?
2.839.
2.839. Okay, all I can say is that it seems reasonable because I know 95 is the biggest angle, so I know my answer had to be smaller than that. I know beta is a little smaller than alpha, so I would expect B to be a little smaller than A, maybe 2.5, 2.6, somewhere around there. But I know it can't be less than 1.2. How do I know that? Because A plus B has to be bigger than 4. If B comes out to 1, 2.8 plus 1, it's not bigger than 4, that's a problem. So it's somewhere between 1.2 and probably 2.5, 2.6. So at least I know what I'm looking for. Okay, let's find B. Start with the, you can start with either the part that you don't know or the part you do know. It doesn't matter. So we'll do sine 40 over B. And the right-hand side is exactly the same as what we just did. Stick with the row that was, it wasn't given, but at least the numbers are nice. Don't use a decimal in the calculation. Okay. So sine 95 over 4. Okay, so cross multiply, you're going to get 4 sine 40 equals B sine 95, and then you're going to divide by sine 95. And we need the decimal for that. Does anyone have that as a decimal? Yeah?
2.581.
Okay, so that's in line with what we expected. Definitely bigger than 1.2, but a little bit smaller than A, and that's good. Had alpha and beta both been 45s, well, then you would have had a 45, 45, 90. But in general, if you have two angles that are the same, use that to help you you have two sides that are the same. That would speed up the process a little bit. Okay, but they were a little bit different here, so you have to do it out twice. Okay, any question on angle, side, angle? All right, so let's look at the next one. So this one, A is 3, B is 2, alpha is 40. And I've put it in the table for you right there. So let's sketch it and see what type we've got. A is 3. So that means alpha is across. B is 2. Beta we don't know. C we don't know. Gamma we don't know. Okay, what type is this one? Using the A and the A's and S's. Yeah.
SSA.
Yeah, it's SSA, side, angle. If you go back in your notes and look at it, that is one of the three types that uses law of sines. Also, look at the table. You have a row that's complete. You also have a row that's empty, and you have no way to find anything in that row. The fact that you have a row that's complete tells you it's law of sines. The fact that you have a row that's empty and you can't do a thing with it, that tells you it's the side-side angle case. All right. So this kind of problem, you have to find three things, but you have to find them in a certain order. What do you think you have to find first here? Yeah?
Beta.
You have to find beta first. And then, once you have alpha and beta, what could you find next? Yeah?
Gamma.
Then you could get gamma, and then once you have gamma, you can finally get what's across from it, C. So kind of the order here is beta, then find gamma, then find C. You have to do it in that order. Okay, so let's set it up to find beta. So first part, pretty straightforward. Sine of 40 over 3 equals, and there's no option, you got to find beta. Sine beta over 2. All right, so we cross multiply just like always. 2 sine 40 equals 3 sine beta. What would be my next step? Yeah.
Divide by 3.
Yep, divide by 3, because the goal is to get beta by itself, but before you can do that, you have to get all the numbers that are outside of the trig function on the other side. So divide by 3, divide by 3, and now we have 2 sine 40 divided by 3 equals sine beta. What would be my next step? Yeah.
Did you do the inverse sine?
Yeah, I'm going to take the inverse sine of each side. Inverse sine, inverse sine. On the right, it cancels out. And let's do it on the left. So second inverse sine of 2 sine 40. Close the parenthesis, divide by 3. Close it again to end the inverse sine argument. Okay, so we get 25.374. But we're not done with beta yet. How come? What else do I have to do that we've done all along? Like if that was a problem in last night's homework, it's something else you have to do now in that step. One other thing. Yeah?
And the sine beta? Oh,
No, not the sine and beta, but yeah.
did you do 180 minus the reference?
Yes, you have to check for a second answer. Okay? Whenever you do inverse sine, if the answer is in a quadrant, which this one definitely was, 25.374, you have to check the other quadrant. Now, why did you say 180 minus? Why didn't you do 180 plus or 360 minus?
Because that's how you find angle for sine in that quadrant.
Well, what's special about sine in that quadrant? Because you could do sine in this quadrant or this quadrant if you wanted. But what's special if you do it in quadrant 2 that makes sense in this problem?
It's positive.
It's what?
Positive.
Yes, it's positive. You wouldn't want to be looking for an answer that's negative. That wouldn't make any sense. So you wouldn't even bother with these two. But you do have to bother with that one. So let's check the second answer. 180 minus the reference angle. So 180 minus 25.374. I'm not going to write it down yet in the box. I get 154.626. You have to decide if the second answer works. Sometime it does, sometime it doesn't. Does 154.626 work? Does it make sense in this problem?
No, it doesn't.
No. Why not?
Because 154 plus 40 is over 180.
Exactly. You were given a 40-degree angle to start with. You can't fit a 154. So in this problem, the second answer doesn't work. You don't have to worry about it. So that means there's not going to be two answers for gamma. There's not going to be two answers for C. Had the second answer worked for beta, then there would have been two answers for beta, two answers for gamma, two answers for C. Not harder, longer. You have to do basically the same problem twice. So, whenever you're solving a side-side angle problem, you could end up with one solution, two solutions, or no solution. The one we just did the one solution case. In terms of length of time, this one's kind of in the middle. Takes about the same amount of time as the other problems we've done. Two solution takes longer. No solution, very quick. You find out right away there's no answer, and then you just stop. Side-side angle is the only case that this can happen. It will never happen with the other two cases we did today. It'll never happen with any other case we learn next week. Side, 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 angle, side. This is the only case. And if you remember what we've been doing, the ASTC diagram, you don't even really need to think about this. Because I didn't even show you guys this. I just asked you, what else do you have to do with beta? And somebody knew, subtract it from 180 to check for the second answer. So that should just be automatic anyway. Anytime you do inverse sine, you always have to get the second answer. It just doesn't make sense here. Okay, so questions on how we got beta? Any questions on how to find the second answer doing the 180 minus? Because I have directions written out for that if you need it, but I'm guessing most people know how to check for the second answer because we've been practicing that all along. You just do 180 minus your reference angle. And then, like Dylan said, it wasn't possible to fit it because when you take what you were given and the possible answer, it adds up to greater than 180. Okay? So that's how you get the second answer. All right. Now we can get gamma. 40 plus 25 gives me 65.374. Subtract that. Now I finally have a piece of information in the last row, which means I can use that to now find what? Yep. Now I can find C. Okay. We've had this choice before. We have two complete rows. Which row should I use? A or B? Yep. A. So I'll start with that. Sine 40 over 3. Equals. And J, and what would go on the other side if we're finding C?
Sine 114.626.
Yep.
Over C.
So sine 14.626 over C. Cross multiply. 3 sine 114, 626 over sine 40. Type that in, and that's your answer. Okay, before I type it in, I'm just going to take a quick look. It's the biggest angle, so I know it has to be bigger than 3, but I know that it can't be bigger than what number? It's bigger than 3, but definitely smaller than, yep,
5.
it's got to be smaller than 5, because if you add this one to this one, they have to be bigger than the third side. So the answer is between 3 and 5. Does anybody have, where did we do it? Right there? Type that in. Yeah.
4.243.
4.243. Okay. And that's a side-side angle. So for today, we just focused on the one solution case. Tomorrow, we'll look at the two solution, no solution, and I'll actually draw a picture. I'll use like a protractor and I actually measure angles and show you how you could draw two triangles given the same information in this particular case. It doesn't work in any other case. All right, so on 435, in the book, I want you to try 5 through 8, 10, and 16, and then I made up 2 other problems. That's an alpha if you can't read it. I know the font looks a little weird. It's not an A though. Okay, so these are 2 additional problems. In the first one, alpha is 70, beta is 60, C is 4. In the second one, alpha is 45, beta is 40, and C is 5. Okay, so we'll take a look at that tomorrow. We'll finish law of sines tomorrow. We have our test on Friday. Remember, I am after school today. My extra help day will probably be Wednesday till at least through the first week of April because we have a class here on Thursday night, so I need to move my extra help to Wednesdays.